Right on time.
Okay, 7:30. Let's get started with our pre-midterm discussion. Any question for me? I didn't see anything on the web discussion page. Let me see if there is any last minute question. No. So it's up to you guys. How do you need to lead me on what to discuss?
This isn't specific questions on the topics, but regarding kind of the instructions. The A4 size page, is that is A4 just standard like printer paper? Is that printer paper?
That's standard.
Oh. Okay, thank you very much.
Is there anything else from you guys? Any topics you want me to discuss? Any doubts you want me to clear?
This is another question involving kind of the rules. So we are to use the Respondus lockdown browser for the midterm. And then it says you will be present through a Zoom session in the regular class. So I assume we can't use our computer to do that. So we would use the phone.
Yes.
It says kind of you use the phone to contact to the Zoom. So we are allowed to have our phone with us.
Yeah, exactly.
Okay.
I trust you students, so don't worry. Okay, so you can use your phone and you can use your calculator on the phone. I just believe that you won't do anything mischief there. But anyway, that's my trust upon you. Okay.
Professor.
Yes.
So what's like, is there a reason, like, are we gonna have to check in on Zoom while we're taking the test? Or?
No. What I recommend, if you have any question or doubts that, okay, question is not clear or what is being asked for, you can just call in, like you don't need an application, right? I believe, let me just double check. I believe I have the phone call information there, right? Let me see, copy invitation.
Sure you do. So you don't want us there. Like if we leave during the test, that's okay. If we're not in there, okay.
I can see you on the Canvas exam page that whether you are taking the exam or not. Yeah. So yeah, Zoom is only to communicate with me during the exam. If you have a doubt on a question or anything, just phone in.
Okay, got it. Thank you.
Yeah, make sure like go to that Zoom invitation that you got it after the registration. It must have a phone number. I hope I have turned on the phone communication. Where can I check? Let me go to the Zoom website, my account, meetings. This one, right? Registration. Let me just see what kind of registration it has. Okay. Yeah, there are dial-in number, US dial-in number. You need to enter basically the meeting ID is there. Maybe a passcode involved. I don't know. Yeah, or you can use another smartphone application, Zoom application, to connect it. That's okay too. Or if you have another computer, you can use that. Any other question?
Yeah, Professor, about the components of everything we've been taught, could you just go over, some of the things we need to know, like a NAND gate has two PMOs that are parallel and then two NMOS that are stacked, and how every single component has some of like couple of each. So if you could just go over that, just so you could maybe write them down and it'll be helpful.
Okay, so you want to look at the basic gate structure. That's what you want to go for. It's okay.
Yeah, like how a NAND or a NOR gate is 4 NANDs, and then XOR is could be 4, 2, 3, or 1. Just if you could just go like a D flip flop has to have 2 NOTs and 8 NANDs, and just all the things like main components that we need to know. If you could just break them down so we could write down, just so we have a clear numbers that we can use when we're calculating in our questions.
Okay, so yeah, that's the part of the question actually. Like you need to break it down. Okay, I can show you one or two example how do you break it down, but it's at the end of the day you need to understand and calculate that. It's not a cheat sheet kind of thing. You can make upfront a cheat sheet about that, but I doubt you can cover the various components that we need. Like there can be several combination of things to get into one specific logic function. So I can definitely show you some of the basic things, but at the end of the day, you need to understand yourself and how to break it down. So, for example, you are talking about this NAND gate. Let's start with that one. Okay, just hold on. And a NAND gate two-input NAND gate is basically your 2 PMOS stacked up with 2 NMOS. Okay, and similarly your NOR is 2 PMOS stacked up with 2 parallel NMOS. An inverter is just 1 PMOS and 1 NMOS. Okay. So this is the basic transistors divisions, or like number of transistor calculation picture, you can say. It's basically 2 NMOS, 2 PMOS for and an OR, and 1 PMOS, 1 NMOS for the inverter. Then based on that, you are going with, let's say, S bar, R bar latch, right? So S bar, R bar latch would be something like this, right? Okay, so this is S bar, this is R bar, Q and Q bar. So you can well imagine it has a total 4 MOS and 4 MOS here. So it is 8 MOS. And then from here, if you want to go with a controlled SR latch, so that would be something like this. What is that? SR latch with the control. Oh, okay, yeah. So this one, no. Wait a minute. QQ bar. So that means we are talking about 4, 4, 4, 4, total of 16 MOS transistors there. So this is your D latch, no, SR latch with control. And then from there, if we want to construct a D latch, it would be something like this. Those are all part of your slides, right? And here is 2, like 16 plus 2, 18 MOS. This is your D latch. Now, similar trend with a D flip-flop, what do you have? Like 1 D latch, and then 1 inverter, 1 SR latch. So from the previous step, we know this is D latch contains like 18 MOS, and this guy contains 16 MOS. So this is like 18 and 16, and this is 2, so it's 36 MOS we're talking about on the D flip-flop, right? So these kind of things you can you need to construct yourself. Like now, from this point, it is okay. Like this is a close-ended. Now open-ended thing. Now if I say, okay, you have a 8-bit D flip-flop or 16-bit D flip-flop, it's basically replication of this whole circuit 8 times or 16 times. So you are basically trying to multiply that on top of these. Things get more intense when we are talking about your multiplexer, right? We can have like, let's say 1-bit 4x1 multiplexer. We can have 1-bit 16x1 multiplexer, 24x1 multiplexer. So combination is infinite. So you need to really understand what is a basic multiplexer looks like and how you extend on top of that multiplexer to make more number of inputs there. And these marks, it depends on what is the inner decoder, right? For a 4x1, you have to have like a 2x1, 2x4 decoder, line decoder. And that line decoder will have like 2 inverter and then 4 AND on top of each other. Something like that, like 4 AND. That's the thing. This AND is nothing but a NAND plus NOT. So you see, like we cannot really put in a cheat sheet kind of thing, like what components goes to what. So you really need to understand deeper detail, like the structure about those components. You study them and make sure you can construct them for a given problem. Does that like make sense?
Yeah, that clears things up a lot, actually.
Yeah, so you really need to like look at the components, study them, and make your own strategy. Like you need to build up on fly those components depending on the given problem. More basic components, you can probably do this kind of calculation and put it on a cheat sheet. But they're simple, right? So whether you put it on a cheat sheet or just do it on fly, doesn't matter. It doesn't take much time. Real challenge is these complex components, which we cannot put it on a cheat sheet. It really depends on the problem, okay? So you need to make sure you understand the inner structure of this component and how you are going to implement them. Okay, what else? Nothing?
If no one else has a question, I can ask more. So for for module 5, as someone stated before, we don't have any problems assigned to us so that we could go over. Could you maybe come up with a problem and go over a problem just so we know what kind of problems we can expect from that module, or would it be similar to the pop quiz?
It will be mostly like a pop quiz and quiz. Okay, this one, by the way, one quiz is coming up this weekend, right? Friday, tomorrow it will be up, and it will due on this Saturday midnight, which includes these questions on this module. So it is more like, let me see. First of all, big problem is out of scope as an online exam, as I explained last day. Like big problems are more like drawing the schematic and given some like some criteria. Okay, design this kind of data path or that kind of data path. You need to come up with a schematic diagram out of that. So those are more like paper pencil question. Online, it is out of question, especially because like Canvas doesn't give an editor which can draw a diagram. Okay, so I'm kind of bound by that one. So I cannot give a question like a draw a schematic diagram kind of thing. However, like quiz style question, pop quiz style questions, like it is more like a theoretical aspect of those study would come up with that kind of scenario. Let me see if I can give, we did a pop quiz on this thing, right, last time. It is, so your this quiz 2, right, it is from lecture 6 to 11, which is pretty much from the basic gates and all the components, all these different gate counts, right? And like given a simple logic diagram, I can ask you like what is this component is, right? So just to draw that there is a D latch we have drawn with 1 inverter 4 NAND within schematic. I can just give you that drawing and ask you, hey, what is this component, sequential component? Is it a D latch? Is it a SL latch? Is it a S bar R bar latch? That kind of thing. Other than that, maybe what like, let's say, again, like gate count problem, right? We did for the multiplier or MOSFET count problem, and we did for like ripple carry adder. Maybe question like how many XOR gates are there in a 64-bit ripple carry adder circuit, right? That kind of things would come up. And then let's say it is all small, like it is more theoretical. If you are clear on the theories, you should be able to answer them. For example, like how many 32-bit 2x1 multiplexer is needed to implement a sign division, right? You need to recall the sign division circuit and see how many multiplexer are needed there, that kind of thing. On the lecture 11 side, it is more like, for example, like if you are considering instruction fetch data path, which of the following component are included in the data path? Like we have several components in the data path. We have program counter, we have instruction register, we have register file, we have memory, we have ALU. So if it is an instruction fetch data path, which are the components are being accessed on that specific fetch? Something like that nature. So it is not a big problem. It is more like a theoretical conception asking. Is that kind of clear up your doubt there? What kind of question can be coming up?
Yeah. Yeah.
Yeah, I think quiz 2 will give you more samples and example. And definitely it will, we did some pop quiz that will be there. If you have tried the sample midterm, that has sample questions there, so you'll know what kind of things you are expecting.
About the sample midterm, Professor, I tried looking for it yesterday. I couldn't find it. I don't know if it was just me. I even Control F tried checking a mock quiz, and maybe it was hidden, but I couldn't find it.
How about others? Did you guys?
It isn't in assignments. It's in, you have to go straight to quizzes. It's not in the assignment. I didn't find it in the assignments folder. If you go to quizzes and then you go to the very bottom, then it's there. It's right there next to the practice final. They're both in their own separate column.
Yep, I see it too at the bottom, under quizzes. Yep.
Oh, okay. Thanks.
Yeah, since these are the practice quiz, so they won't appear in your assignment. These are not assignment to you, right? Okay, what else? Otherwise, we'll just go off, study, maybe continue with the project 2. Maybe we'll study probably, not project 2. I believe most of you are betting on that spring break to complete your project, isn't it? Yep, I see Yorick nodding his head. Yep. Yeah, I hope you wouldn't spoil your spring break. If you had completed before that, then you could have enjoyed your spring break, but nonetheless, it's your choice.
How much travel and fun is there to do during the spring break anyway? So honestly, like, it's work time, one way or the other.
Okay, all right then. Then good luck with the exam. And yeah, see you on the exam. And remember, like, quiz coming up tomorrow, it will be up, due by Saturday. On the exam day, I'll be available over the Zoom. You don't need to log in. Only if you have question, you can dial in or log in through other application, your smartphone or another tab if you have. Just log in through that, or just use your phone to call in, dial in and ask me question if you have any doubts on the question.
Sorry, when is this you're referring to?
Was it?
When are you talking about right now? Which for which quiz or test or what?
So quiz number 2, that will be up tomorrow, right? Yeah. Quiz.
And what are the times you'll be available?
Oh, this is from, I think, morning 6 o'clock. Tomorrow morning 6 o'clock it will be available.
But what about you were saying you will be available to help us.
Oh, for the exam, it's the same time. It's the same time as in 7:30 till. I'll try to log in before that. Like, I think your exam is open 10 minutes early, right? So I'll try to make sure that I also log in 10 minutes early on that same Zoom meeting. Okay, so that means we're talking about March 23, about 7:20. I will log in into the Zoom.
One question.
Yes.
So we can have a cheat sheet, right, for the midterm?
Yeah.
Yeah. So can we type that up?
Sure.
Or... Oh, okay. Thanks.
Yeah. I know, like, people think of like putting it really small font and use the, like spyglass to look at that and stuff like that. Believe me, what I found out, those things doesn't help you. Okay? Those things absolutely doesn't help you. So main thing is the conception. Yes, it will help you probably here and there a little bit of things, but if you try to cramp in everything into like 2 pages with a very small font, you'll waste your time basically there. Simple. Okay, so judge yourself. Look at, okay, this is the thing, like, please look at the practice midterm and make sure you know what type of things you are going to face and put your strategy like that. Okay.
Okay, thanks.
Okay, all right then. Good luck, everybody, and then we'll touch base on the next day. Hopefully, not much question comes up on Tuesday. I'll keep on watch on the discussion. By the way, okay. If you have any doubt question, you can put there. I try to answer it over the discussion board as well. And then we'll have our next regular class on the Thursday, coming Thursday, which is March 25. All right. Good night, everybody. Then.
Yeah, Professor, if no
Yes.
one else has a question, I had another question.
Oh, sure.
So about the project. So working on the project, you know, there's a lab 8 that you put up that talks about the state machine implementation. So the state machine that's on them under the lab, it's basically a state machine that accepts the value 0, 0, 1, 0, 0, I believe. But in this case, we have 6 or 7 states for the project: fetching, decoding, then executing, and then all of them, right? So every time, so basically for the project, every time you switch the state, there's a whole new operations that are taking place, correct? Okay, so it's not just like the machine showed in the lab where it's only going to do something.
I believe that lab has a state machine depending on the incoming input. But this state machine in this project, in the process of the test, that state machine is basically independent of any external input. When it starts, it's always cycles through that 5 state, like instruction fetch, instruction decode, execution, memory, and write back, and then goes back to the instruction fetch. So without influence of external input, it always goes like this. And per state, your controller need to take some action.
Okay, I see. And when we reset the states and we go back to the first one of fetching, would that also reset our counter value in the register?
Of course.
Oh, okay.
Yeah, I believe nowadays you don't see that reset button in any of this system. It's kind of power off on switch, but in older computer, we used to have a specific reset button. It is kind of a hard reset we call. Like pressing that, it basically kind of restart the whole machine.
Oh yeah, see that's part of the reason why everything's so complicated. We have so many signals going on, so many registers. It just gets very confusing, and there isn't much to look at when you run into an error. I try looking up something online, maybe someone talks about it. There's no one really explaining it online. So what exactly is where can we go to actually like resolve our problems and instead of just asking every single one to you?
Yeah, in my office hour, and discuss within your group. This is the like a different domain you are dealing with. It is a hardware domain, and you won't get much help online because like only, as I told, like only probably 5% of entire population, like high-tech population, knows the hardware. Okay, so and they are like all these processor house, design house, they're all closed camp. Like they don't really let out the secret out. It is more like a theoretical. That's why you won't get any help or much help online on this. So best thing, you come to me, talk to me, discuss with the study group, and go through thoroughly. Like every statement is important in the lab and in your this guide on the project.
Yeah, I guess the guide is a big thing. Literally every single word, it affects a lot on the project itself. But I was talking to a couple of students from last year. There's still 34 people in this. I just want them to hear this too. They said the only reason why that class did so well, they said they were the whole class was together and they constantly resolved each other's problems. In our Discord chat, no one is asking any problems. Even in this class, no one's asking any questions. So I just don't think it's gonna lead us very. I mean, some of course some people are always gonna get good grades because they're very smart, but majority of us we actually need to communicate and work this out, because we could ask every single question to you, the professor, but like some questions I might know some answers that someone else might know, and we can help each other out, but no one's really been doing it. So I just
So that's what the study group is, and that's what just try to put out a question on the discussion. There is a project to discussion in the discussion page. I hope like others will jump in if you have a question. Others jump in and give some answer.
Okay, yeah, I got it.
So try to put questions on those project discussion.
I think we should just all participate a lot more in the Discord, maybe when we're studying or something.
Yeah, that'd be good.
Yeah, so I don't know whether you are joining that Discord or not, but yeah, you can just talk to other student, get the Discord link. Yeah.
Okay. If no one else again has a question, I have another one. It's about.
And by the way, is there a tutoring for this class? I have seen in past there are tutors for this class.
I heard someone talking about it. Someone told me there might be one. I haven't looked into it. If you know anything, maybe let us know. That'd be great, actually.
I can tell you, at least through the College of Science, there is not.
Oh, okay.
The College of Science only has the algorithms class, CS146, not for 147.
Huh, that's interesting. Maybe you guys can talk to some of you, just go in a group, send them an email or contact them as a group and ask them, do you guys need a tutor? I don't know how the tutoring works there, but yeah, something you can, or you can talk to the department and see if there is a tutoring available there. I'll try to figure out like if there is any.
Okay. If no one else has a question, I had a question about so once we actually implement everything and we're going to be reading the instructions from a file to our program. So apart from having the correct name of the file, is there anything else that's very important in order to start reading each line of code, the opcode, and then the register address and what we're doing, each instruction apart from the name of the file?
Yeah, it has to be on the same directory as you create the project. So my suggestion would be, when you download the whole package, you unzip the package in one directory and create your project on the same directory, so that when that inside the code, Verilog description, when we refer to like load some program, load some file like .dat file, it knows where to look for. It looks for the current directory and picks it up. If you like separate your project definition directory and source directory in a different place, then that might be a source of problem, that you won't be able to load that .dat or memory content upfront in the simulation. So that's one suggestion.
Oh, okay. And another, I think this one's actually pretty straightforward, but about the implementation of the ALU. I mean, of course, we did it in project 1, but for this case, we're gonna have to change the instruction for every single operation, right? It has to match with our the I type and the R type. Like, I think it's 20, 22, 2C. We would have to change it to meet those functions, right?
Those machine code, yes. So you're talking about writing a new test program to test your rest of the implementation?
No, so when we read the instruction, because right now what I have in my ALU is, the first one is performing addition, second one is subtracting, third one is multiplying. We're gonna have to change the first, second, third to actually what we have in the CS47 instruction set, right?
No, so ALU is controlled by your controller. So your controller is really the one who looks at the machine code and parse it, and then see if it is an add instruction or subtraction instruction, stuff like that. And during the exe state, it actually controls the ALU, sends the ALU commands or instruction for addition, subtraction, etc. So controller is the one who is translating from your machine code to the action taken by the ALU.
Oh, okay. Okay, that makes sense. And then of course, push, pop, jump, they don't require the ALU, so that doesn't matter.
Push requires, yeah, you can code it in a behavior without ALU. Get level implementation uses ALU because get level doesn't have any other adder. So you can do it in that way too, but it's okay if you do a separate like addition, behavior addition on the stack pointer, it's okay for the behavioral modeling.
Oh, okay.
Just trying to send your department chair and help note on your tutoring. Let me try to figure out what is the process. Okay, yeah. What else? Tell me.
Yeah, just getting started with the control unit was just the hard part. Like, so for the first state, the fetching, it says set memory address to program counter. So the register for programming counter, we set the address to that. Is that what it's asking us to do?
No. It's my Google Assistant is telling down something suddenly. Anyway, tell me.
Okay, so the statement for the first state is for fetching is set memory address to program counter. Could you just elaborate that a little bit?
So you remember very fast or second lecture we talked about how an processor execute an instruction, right? And it has a program counter register inside the controller, which keeps tracks of the address of the next instruction. So similarly, that means you need to have one register defined inside your controller, which holds the next instruction address. Okay, so on the instruction fetch, you basically picks up that value and get it out, send it out to the memory.
Oh, okay, I see. Okay, that makes sense.
So you see the controller has an output port called address, memory address, right? So you send that program counter value to that memory address.
Oh, okay. Well, that makes sense.
Okay, so yeah, how is your study group? Is your study group active? Or
yeah, we talk here and there.
Okay, all right. And yeah, please start putting up your question and doubts on the project discussion page so that everyone can jump in. And also, as Yorick mentioned, Discord, right? Is it?
Yeah, that's what he said.
Okay. Yeah, so keep the discussion going on.
On the Discord, by the way, you also have an archive of all of the discussion and questions from last year regarding the project, so that might be relevant this year as well, for this semester.
Yeah, that's a good point. Yeah, that's a good point. Whatever problem you are facing now, already been faced with the past student, and they have figured out.
Oh yeah, that's right. Thanks for that.
Okay, what else? Everyone else is very silent today, very quiet.
I guess I'll just say that I talked with my group like a couple times a week, all the time, basically.
Okay, that's good.
So,
that's good. Yeah. Yeah, you guys can help each other in fixing problem. Only requirement that you don't do Control-C, Control-V. Okay, that's the only requirement.
Yeah, I removed those macros.
Yeah. Anyway, anything else, guys? Or we can just stop tonight so that you can go back, study more, do the quiz tomorrow as early as possible. And I'll keep an eye on the discussion page. If you have any other doubts to clear up, just put it on the midterm discussion.
Okay.
All right. Good night, everybody, and good luck for your midterm.